In today's show, we're all going to gather our crystal balls and we're going to try to predict the future. It's not as hard or difficult as you might think. So climb aboard Computer Train and I'll show you how to do it.
It's time for Computer Train, the weekly TV program that trains you how to use your computer. With your host, El Paso Community College faculty member Russ Myers.
Okay, I have to confess, we really can't predict the future. But what we can do is we can do some analysis that helps us determine what future results might look like. So in today's show, we're going to go back to Microsoft Excel and we're going to do a little bit higher level example than I normally show, but I think you guys are ready for it. All right, so come aboard and let's see what we're going to do today. What we're going to be doing in Excel is we're going to be using a concept called what-if analysis. Okay, and a lot of people have questions like that. When they say what if, they're talking about, well, what if this happens? What if that happens? So what we do in Excel is we have formulas. So we've had quite a few shows on Computer Train where we've used Microsoft Excel and we've built lots of formulas. Those formulas are usually based upon cells that have values in them. So what if analysis is we're trying to see what would happen to the results of those formulas if we were to change the values that that formula is based upon. Okay, so it's as simple as that. If this cell is a 10, what happens to that cell? Okay, a couple of ways to do it. One is a manual method. From the first time I've done this show, the idea that I've been trying to get across is that the reason we invented computers is to make things more efficient and easier to do. Unfortunately, as I've shown you, many people use computers still and do a lot of things manually when they don't have to. So the first step is a manual method, and that's called trial and error. Basically what that is you go to the cell that has the value and you physically change the numbers and you look. You type another number and you look. You type another number and you look. Unfortunately with that is you can't remember the results of the previous numbers. Then you continue and it's more cumbersome than you normally would have to do it. So there are a couple of basic tools and there are some more advanced ones. We're just going to take a look at the basic tools. All right, so there's some Excel methods to do what-if analysis. And the first one is called data tables. And just as the name implies, what we're going to do is off to the side of our data, we're going to build a table of information that shows you if the value was this, here was what the result would look like. If the value was this, and you can kind of study it with the numbers side by side. First tool is called a one variable data table. Okay, and as the name implies, you can only analyze one cell here. You can only change the values in a single cell. A lot of times I joke around with my students because sometimes they don't get these questions. How many variables in a one variable data table? And of course my classroom is completely quiet. Well, as the name implies, there is only one variable. Now the nice thing about this one is you can analyze its impact on several other cells. And what I mean by that is if that one cell actually affects various cells related to formulas, you could see what the impact would be on all of those other cells, whether it's two other ones, three other ones, multiple ones. Okay, another variant of that is a two variable data table. Okay, so a two variable data table, once again, as the name implies, you can change two different cell values that are used in a formula, but you can only see the impact on one cell. You can't see the impact on those values on numerous cells. If you have multiple variables and you want to see the impact on multiple different formula cells, you would have to use those higher level tools. Okay, so the main gist of the show today is to show you these data tables. Like I usually do along the way, I'm going to show you a couple other things. The other thing that I want to show you is a concept called named ranges. And what we're going to do there is we're actually going to give a cell a name, a text name. And what that allows us to do is when we build the formula, instead of seeing the cell reference in the formula, such as B10, E17, we'll actually see the name. And what that helps us do is more easily read formulas and more easily fix formulas that may not be working properly. Okay, I have a very simple example to demonstrate a lot of this. First one, we're going to use a car loan example. So it may be something that a lot of you might be doing. Okay, so let me zoom in a little bit and make sure we can see the data. All right, so here I have the data for a simple car loan. Okay, so we're pretending that we're going to buy a car, so we need to borrow $20,000. We have an interest rate on our loan of 5% per year. And we're going to make 60 payments, which is 60 months. 60 months is the normal consumer loan for a car, 5 years. So from these pieces of information, we're going to build a function and formula to compute the payment. Okay, so the values that these cells are in are B1, B2, B3. Instead of seeing that in my formula, I'm going to give those cells a name. Very simple to do this. Okay, so you click on the cell you want to name. So for instance, I'm going to name cell B1. To name it, you come right up here to this window. This is called the name window. It usually shows you the cell reference that your active cell is in. Instead now, it's going to put the name of that. One thing to remember about named ranges, you cannot use spaces. And usually we use a capital letter on the first word of whatever description we're using. So I click in there, and we will call this loan amount. Okay, no spaces. I'll call the next one, so I'll click on the cell, and we will call this one annual rate. And basically this 60 represents the monthly payments, how many payments we're going to make. All right, so now we're going to use a function. We've used functions in Excel in previous shows, but just to remember how to do it, we're going to go to our formulas ribbon, and we have a function library. I was reading about Microsoft Office 2016, and specifically I'm using Microsoft Excel 2016, and the new version of Excel has 333 functions available to you. So as I've described before, that's why it's such an awesome program. For anything that you can possibly think of doing numerically, Excel is ready to go. This particular function is in the financial category. Okay, so I'm going to click on the financial list, and we're going to use a function called PMT. PMT. Okay, and as you can see, it computes the payment for a loan, which is exactly what I need to do. All right, let me move this off of my data a little bit. And remember, in order to use functions, all 333 of those functions, each one of them requires information in order for it to do what it does. Those individual pieces of information are called arguments. When you put in the value for the argument, it has to be something that Excel is expecting. The example I used in a previous show is if I asked you to give me a number between 1 and 10, you can't say table or computer. That is not a number, and you would get an error message. Even if you give me a number like 15, it's not within between 1 and 10, so again, you would get an error message. All right, one last thing about this particular example is this is a finance example. You have some people that have a little finance knowledge and might be able to show you a little bit about finance. You have some people that might have a little computer knowledge, show you a little bit about computers. But there's only a few people that have finance and computers and can combine the examples. All right, so when you give it these pieces of information, you have to make sure you give the numbers in the same time frame. And what I mean by that is in this example, this 5% represents a yearly time frame. It's 5% per year. But this 60 represents months, 60 months. We either have to convert this to months or convert the months to years. Okay, so we remember that in finance. Always worry about time values. All right, so what I usually do is make it match the frequency of the payments, which is monthly. So I'm going to take the annual rate, and we're going to divide that by 12. But if we can zoom in just a little bit, I want to show them the benefit of that named range. So if we look here, if I had not used a named range, remember I pointed to cell B2. So instead of saying cell B2 now, it actually uses the name I gave it. And what that helps me do is as I have formulas and I'm trying to figure out where I'm getting all this data from, I can just remember the names of things, and it makes it much easier to follow the data and the formulas along. Okay, so I take the yearly rate and divide it by 12 to convert it to a monthly rate. Sometimes in arguments for functions, the data is readily available and you just click on it. Other times you might have to calculate a little bit to come up with a new value. And sometimes you might have to use a function inside a function to calculate that new value. I don't know if we're ready for that. I'll have to talk to my producer. All right, second argument is the number of periods, basically is the number of payments you're going to make. So that is this one. Once again, notice it says monthly payments. In an example for loans and finance functions, PV stands for present value. In a loan example, it's essentially the amount of money you borrowed. Present value is if you don't allow for inflation. Okay, so we'll click on cell B1, which of course says loan amount. Okay, we're going to go with the defaults for these two other functions. So let's click OK. And because of the way that Excel does financial functions, usually it will display the numbers in a negative fashion. That's what this parentheses in red is all about. So what we usually do in this is we modify the formula and put a little minus sign in front of the whole function. And essentially it's the negative times negative concept where we display a positive. So I'm going to click up here and put a minus sign in front of the P. All right, so that was a good example of a function and also utilizing named ranges. So if we were to borrow this $20,000 at 5% per year and make 60 payments, our payment would be about $377. Okay, so the what if analysis part comes in where people start asking you questions. Okay, well, what if I only borrow $18,000? What if I borrow $22,000? What if I borrow $25,000? Okay, so the first method I discussed is trial and error, where you just type it yourself. So if I was doing trial and error, I would type the value and change the loan amount. Then I would see the impact on the cell that has the formula. Okay, so what if they did want to buy the $22,000 car? What would that do to the payment? So I changed that to $22,000. And that tells me that the loan payment would go to $415,000. Okay, and we could continue the process, but by the time I answered the question about what if it was only $18,000, then they're going to ask me again, what was the $22,000 amount? I've already forgotten. So instead what I can do is I can build a data table and I can have all of these different loan amounts and I could show them what would happen to the payment. A very simple little analysis tool that I used actually when I bought a new vehicle. All right, so to build the data table, you just need to pick an area off to the side or below that has enough room for your data table. So I'm going to put it off over here starting in cell D1. First thing you do is you put your column heading for the cell that has the changing variable, which in this example is the loan amount. So here's where the amounts are going to go. And then you put the column headings for the cells that contain the formulas that you're trying to see the result for. I'm trying to see the impact on the payment, so I would put payment here. By the way, that's not for Excel. Excel does not care about these column headings. Column headings are usually for humans to be able to read the data. Excel just focuses on the data. All right, so here's a critical first part of getting this working. In this first row here, below our column headings, we set a formula, single cell reference formula, which means it's not going to be a calculation or anything like that. We're just going to point to some cells. And that sets up how Excel will build the data table. It's only one component, but it's a very major component. All right, so essentially we're going to press the equal sign there. And we're going to tell Excel where the amount is. Okay, so the loan amount is in cell B1. Okay, and that is called a single cell reference formula. It's not a calculation, it's not utilizing a function, it's just whatever is in that cell will be displayed in this cell. And we do the same thing for the payment. Click on that and click on payment. All right, notice it says B5 because if you recall, I didn't name that cell, so it reverts back to its cell reference. All right, so now what you do is in the amount column, you're going to type in all the different values that you want to analyze for loan amount. So you probably would come up maybe with a range. Let's say the person wants me to analyze all the values from 18,000 within their budget maybe to about 24,000. And usually you put an increment. So I'm going to show them 18,000, 18,500, 19,000, etc. If you recall from an earlier show, you can get a sequence of numbers in Excel very easily. You have to type the first two. So I'm going to type the 18,000. Then I'm going to type the 18,500. Big thing here is you select both cells, not just one cell. If you only select one cell, you'll get 18,500 all the way down. Then you point to the little square on the far right, which was called the fill handle. Okay, so that little cross right there is called the fill handle. It has many uses. Usually we use it for a fast copy and paste across contiguous cells. In this example, we're getting it to fill up numbers. So then we're going to go all the way to 24,000, and notice it's very nice I don't have to type all of these. Okay, so you type in all of the values for the what if questions you want for your loan amount. Okay, very easy to finish this up now. So after we select our entire data table, the tool that we need is on your data ribbon in Excel. Okay, over here to the far right we have forecasting, which we're predicting. Remember, I started the show, we're trying to predict the future. We're not really trying to do that. What we're trying to show, if numbers happen in the future, what would be the results of that in our formulas. Okay, and one of them is called what if analysis. I don't know if you want to take a little closer look at that. There's a question mark on it, and it's called what if analysis. Okay, so in the what if analysis, there's a button for the data tables. You would go to this same dialog box if you're creating a one variable data table or a two variable data table. It's the same dialog box. It's just how you started the table and what you complete in the dialog box is the difference, and I'll show you. So I'm going to go to data table. All right, the last thing it needs to know is this input cell. And the input cell is essentially the input numbers to the problem. Okay, and again, if you were doing trial and error, that's the cell where you would be doing the typing, not the looking at the results. So I would be doing the typing in the loan amount. Essentially, what this question is asking you, just like if a person was going to do this, it's asking you, where should I type these numbers? Okay, well, we would either, if I was doing it or Excel is doing it, I would type these numbers in loan amount. So I'm going to tell it the loan amount value. Now the question is, which one of these text boxes to fill out, or do I fill out both of them? The answer is, first of all, I'm doing a one variable, so I only fill out one of these. If you're doing a two variable, you would fill out both of them. Then you can type your data table kind of a different way. Instead of having your input values go in a column fashion, you could have them going across in a row fashion, depending on how you wanted to construct the data table. I typed mine in a column fashion. So I'm going to fill out the column input cell. I'm going to fill out that text box right there. And again, it's asking me where to type these input values, and I'm going to be typing that in cell B1. Okay, so essentially what Excel is going to do, and it's going to of course do it much faster than I could do it, it's going to type all these numbers in there, get the value for this, and fill out this column. How does it know to get the value from this cell? We told it right here. That's what this cell is doing. We're telling it to get the values from the payment. So we click OK. We probably want to format it a little bit, make it look a little bit nicer. Okay, so I'm just going to do that quickly. And there's our analysis. Obviously, the more money you borrow, if everything stays the same, so they could kind of see a payment range of the car they're looking for. If they go down as low as $18,000, their payment would be $340. As they add numbers, it's going to increase the payment. If they went to the top end of their budget, let's say $24,000, that payment is going to work out to be $453. Okay? And that data table just helps me do the analysis. I can kind of look at the numbers side by side. I don't have to try to remember what a particular value was for a loan amount. All right, so that analysis was on one variable to a problem. Now let me show you another perfect example for a two variable. In my Excel classes, I have them build what we call as a grade calculator. Basically, we build formulas so they can keep track of their grade and they can see what their grade is at any moment. Okay, very simple. In my classes, you take your total points earned, you divide by the total points you could have earned, and that gives you a percentage. The percentage relates to a grade. Okay, so I don't know why. Usually students don't worry about their grade too much until the last couple of weeks and they come knocking on my door and they ask me those what-if analysis questions. Can I still pass your class? Can I still get a B in the class? Can I get an A in the class? Well, if they have their grade calculator, I can show them how to build a two-variable data table to quickly answer that. Okay, so we're pretending at the end of the class this person has an 86%. This person's not worried about passing the class. They're doing fine. What they might think, though, is can I still get an A in the class? I don't know. We need to do some analysis. So at that point, there's only two possible grades left. They have the final exam, and they have this final design project that I give them. So I'm going to show them all the combination of possible grades to see if they can get an A, and then what would it take on these two last assignments. Okay, so to do that analysis, I have to type in what these are worth. Final exam is worth 100, and the design project is worth 50. To start the analysis, just like my variable data table, you have to have room in your spreadsheet somewhere. So I'm going to do that off to the side. Remember, we had to tell it where the changing variable is, and we had to tell it where the result cell that we were looking at. This one starts off a little bit different. In the upper left corner, you give it that single cell reference to the cell you're analyzing. Don't forget, two variable, you can only analyze one result. So single cell reference, I'm trying to analyze their grade percentage. All right, let me widen these cells for a moment. All right, and now what we do, just like we did with the one variable, is we type out our inputs. In this problem, there are two inputs though, final exam grade and design project grade. So I type one set of numbers below and one set of numbers to the side. Okay, so I'll type the final exam below, and this is a pretty good student, so I won't do the analysis below 50. I'm not anticipating they would get less than 50. And I'll do it in increments of 5. So once again, type the first two numbers, select, and I'll go to the highest possible grade for the final exam, which is a 100. Then, to the right of that, I put in the other inputs, which is the design project. It's worth 50. In this case, sometimes, for some reason, students don't turn something in, so I will go down to 0 on this one, and then I'll go in increments of 10s. Okay, but you can type in any values you want. I could go by ones if I wanted, if they get a 26, if they get a 27, if they get a 28, etc. All right, same as before, I select my entire data table. Okay, and just like last time, what do I have to tell Excel? I have to tell Excel where to type these numbers, where to type these numbers, and it's going to get the values in the center from what I told it right here, that I want the percentage grade filled out there. Okay, same thing, go to the data ribbon. Same menu, what if analysis, still going to data table dialog box, except now I fill out both of these because I'm doing two variables. The row is the values you put in a row fashion. These were my design grades. Where would those go? In my spreadsheet, if I was doing this manually, those grades go right here in cell B12. Okay, my columns are the exam grade. Those would go in cell B11. Okay, so essentially it's going to type these numbers in these two cells. It's going to see what this number is and fill it out where those two numbers cross. Then I can tell the student what their final grade would be with any combination of those last two numbers. Okay, got a lot of decimals here, so probably want to format it a little bit. So we'll format all that. All right, so the first question they were asking, remember, was can they still get an A in the class? Okay, so I've answered that question for them. If we look down here, I'm going to zoom in a little bit. Can they still get an A in the class? 91% is an A. They can. I don't know. Should I be nice if they get 89.9? Should I round up to the 90? I don't know. If it depends how I feel that day. All right, so the question here is, if you want to get an A in the class, it's still possible, but as the analysis shows, you have to almost ace both the final exam and the design project. But the other thing is, the analysis can also show, you know, they should be very, very comfortable with getting a B. Because all of these numbers where it says 80%, all those combinations where it says 80%, that locks in a B. All right, so if you're this student out there, you can almost guarantee you're going to get a B, and you could still get an A, so hit those books. I hope you enjoyed this episode of Computer Train and another great example of how much I love Microsoft Excel. In the next episode, we're going to discuss it a little bit more, so I hope to see you back next time on Computer Train.